Good morning or good afternoon, dear students. Today's lesson will be a remote teaching module with physics. Main reason for this lesson is why do we remote teaching? Of course, coronavirus is spreading and we are looking for ways we can teach you. I'm going to discuss what do we expect from you guys as students for the following period, and I'm going to discuss questions 7, 8, and 9. It was homework for this lesson. Well, guys know that the coronavirus is spreading, schools are closed, and we are looking for ways we can teach you from a distance. Each teacher is looking for its own way. I'm trying to give you instruction movies or clips, and I'll discuss different questions from the book, or I will hand out some worksheets. All the instructions will be spread out using my gesture. For now, question 7. I'll read the question. Of course, you have already made it, and then I'm going to discuss the answers and which steps you have to take. It's question 7 on page 143 of your book. Joseph first heated 100 grams of liquid A in a calorimeter and then 100 grams of liquid B. He used the same 12-watt heating element in both cases. You can see the graph of the two experiments in figure 9. Which liquid has the greater specific heat, and how can you see that? Well, the bigger the specific heat, the more heat necessary to heat up 1 gram of material 1 degree Celsius. So line B has a bigger specific heat, and how can you see that? It's not as steep as line A. For line A, you don't need that much heat to heat up the liquid. For line B, you'll need more heat, and that's the reason line B has a greater specific heat. Which of these two liquids could be water? And show how you got your answer. Well, this is a little bit tougher. Line A, you can calculate the amount of heat supplied using the specific heat formula, mass times the specific heat times delta T. The mass is 100 grams and the specific heat of water is 4.18 joules per gram per degree Celsius. If you multiply it, you get 10,450 joules. For line B, the mass and the specific heat will be the same because you estimate it's water, and that's 4.18. Only the delta T is twice as much because that's 50, so you'll need 20,900 joules. Are you there yet? No, you need to know how much heat is supplied, and that's calculated with this formula. It's also discussed in paragraph 4.1. The amount of energy is the power times the T. The amount of power of the heating element is 12 watts, also known as 12 joules per second. The time, 15 minutes, and that's 900 seconds. So 15 times 6 is 900 seconds. The amount of heat supplied is 10,800 joules. So line A could be water because that's pretty close. Question 8. Joni fills the electric kettle in figure 10 full with water at 20 degrees Celsius. She then turns on the appliance. Calculate how long it will take at least until the water boils. Well, this is always the first step. Write down your formula and write down the data you know, m, c, and delta t. Well, the m is the mass, it's 1.7 liters. That equals 1.7 kilograms, and that equals 1,700 grams. You know the specific heat, that's 4.18 joules per gram per degree Celsius. And delta T equals 80 degrees Celsius. In this case, you know the Q, the amount of heat supplied, it's 586,480 joules. In this case, you can calculate the amount of energy supplied, and that's the power times T, only you want to calculate T, and the time it takes. In this case, the time is the energy divided by the power. Only you don't know the energy. Well, actually, you do know, because in this case, you can determine that Q equals E. So your answer from this first step, you can fill in the next formula. The power is also given. It's 2,200 watts. So the time it takes is your answer from this step divided by 2,200. And then you get 258 seconds. Question 9. Ellie makes 1.5 liters tea at the campsite with a Bunsen burner. She heats the water from 20 degrees Celsius to 100 degrees Celsius. Unfortunately, 50% of the heat produced flows past the pan and is lost. The fuel produces 46 kilojoules heat per gram. Calculate how many grams of fuel she uses. Well, the first step is, just as the previous question, Q equals m times C times delta T. You know the amount of mass, 1500 grams. C and delta T still remains the same. So the amount of heat supplied is 501,600 joules. And that's the amount of heat necessary to heat up the water. In this case, you'll need twice the amount because of the energy loss, so 1,303,200 joules. You know that 1 gram produces 46 kilojoules, and that's 46,000 joules. Then it remains that you have to divide 1,302,200 divided by 46,000, and then you get 21.8 grams. These are the answers for questions 7, 8, and 9. If you're looking for more steps or you think these questions are a little bit tough, please send me a message through Magister or pause the video a couple of times and then you can see the different answers. For the next lessons, I will add some translated questions from the Dutch book so you can prepare more for the big test using the different energy questions because a lot of them aren't in your TTO book. Good luck next time.